It's away. It says it's recording. Now, I'm not going to record the class probably unless somebody's in quarantine or isolation. Okay? So if something happens and you go in quarantine or isolation, you need to email me. So then I can make sure that I've got this thing going. Okay? And those will be thrown up. Now, it may be that if it ends up, you know, we're a little concerned. I mean, I'm a little concerned about bandwidth and everybody on those devices at the same time. It may be that if it works out, I can do every class, but we're just going to kind of play it by ear. But if you're in isolation or quarantine, I'm going to need to video the classes. So I'm trying to see if I have it like all the way out, if you can still read the board when I get upstairs to the recording. Let's see. All right, so we'll play with it in a second. Okay, let's talk about x-intercepts and y-intercepts. Now, class is going to be super boring if I talk all the time and you don't say anything. Okay, and I just really don't want to be bored. All right, so I need you to be back and forth. What does it mean when you intercept a ball, like intercept a football? What's that mean? You got to. Okay, what that means is that your path and the ball's path cross right there, and you hang on to it. Okay, that's the same thing it means on the x-intercept, only it's not a ball. Okay, so what the x-intercept is, it is a point where the graph intersects the x-axis. Okay. Now, every professor's got idiosyncrasies. Okay? So when you get a real job in the real world, your boss is going to have idiosyncrasies. So you have to learn to adjust to your boss's idiosyncrasies. This is one of mine. The mathematics definition of an intercept is a point. How many coordinates does a point have? 2. So don't tell me the intercept's 3. You see what I'm saying? I need to know what the point is. And the reason for that is I know where we're going at the end. So by the end, you've got to be able to draw me graphs without your graphing calculator. On your third test, you won't be allowed to use your graphers. Okay? So I've got to get you ready for that. So I need you to know, is it the point 30 or 03? You see what I'm saying? Now, if you had a picture, and this was your graph, how many x-intercepts does that have? Does it have any or how many? All right. Because you've got one right here, and you've got one right there, and you've got one right there, and you've got one right there, and you've got one right there. Okay, so it's got 5 x-intercepts. Now, I'm just going to make up some numbers. Suppose that's the point that, suppose that's that, suppose that's that. Now, what's the same about all those x-intercepts? What's the same about them? The y coordinate. What's the y coordinate? 0. So this is a note. This is not the definition, but this is a note. If it's an x-intercept, then you know that y is 0. Okay? So if you had a graph like this, let's say, and I gave you that on your first calculus test and said, what are the x-intercepts? Well, now you can take your grapher and graph it. Is everybody with me? And you're going to get a picture that looks like this. All right, let me ask you this. Let's do this. Let's change it to this instead. Both of those graph the same shape. What shape do both of those graphs graph? Lines? What do they graph? Parabolas. Now, sometimes parabolas go up, down, sometimes they go left, right. How do I know when they go up, down versus left, right? All right, the sign tells me whether they go up or down or left or right. But how do I know if they're an up, down versus a left, right? It's by what's squared. Like here the x is squared. And here's what's squared. The y. Which ones go up and down, when the x is squared or when the y is squared? When the x is squared. All right, this one's going to go up, down. Is everybody with me? That one's going to go like left, right. Okay? So if I'm going to go find where the x-intercept is, if you graphed, say, this one, it's going to look kind of like this. Because if I get this in standard form where I have y equals, this coefficient is positive, so I know it went up. If it were negative, this thing would flip and go what? Down. Now, let me warn you about something else. If you hit that tracer key on your grapher, you're going to get a decimal approximation for these. I do not like decimal approximations. So in this class, you always give me exact answers, unless I give you permission not to. Okay? Because in the real world, you have to give exact answers. If you're working at NASA and you're on a team, you're going to have to give the exact answer to the next member of the next team. Because if you give them a decimal approximation and they take your calculation, and now in their work they have to multiply that number by 1,000,000, what if you gave them a little bit of error? What just happened? It became what? A lot. So I'm going to hand the exact answer off. If they want to multiply by 1,000,000 and they get off by a big number, they're going to lose their job. I'm not losing my job. Okay? So you can't do that. So what am I going to do? Well, how would I figure this answer out? Well, now, if you know that you're looking for x-intercepts, what do we say? What's 0? Y. So what does that mean x squared has to equal? All right, so then what does x equal? Is it just the square root of 3? It's a positive square root of 3 or a what? Negative square root of 3. But now if you box that for your answer on your first test, I'm going to count it off. Now why am I going to count it off? Because the next intercept is a what? A point. So what would I be expecting you to write on your paper? Negative square root of 3 comma what? 0 or what? Positive square root of 3 comma what? Those are the x-intercepts on that graph. Okay, question.
Would you also accept like plus or minus?
Yeah, that'll be fine. So this one had 2. Sometimes you don't have any. I mean, if it were this, is everybody with me? Graph looks like that. Where does that cross the x-axis? It doesn't. And see, you would have x squared would have to equal to what? If you solved x squared plus 3 is 0, what's x squared got to be? Negative 3. Are you ever going to square something and get a negative 3? No, that's why this one would have no what? X-intercepts. Okay? So x-intercepts where the graph crosses the x-axis, those match. But what's 0? Not x, but what? Y flips on you. Okay? So similarly, what do you think the y-intercept is? What would be the definition of a y-intercept? Yeah, perfect. So it's the point where the graph intercepts the y-axis. Now, does this graph have a y-intercept? I mean, just one. Now, if if your graph looked like this, is everybody with me? And your graphs sometimes look like that. I'd have multiple ones again, wouldn't I? Now again, suppose that was the point like 0, 4/3. And that was the point 0, 3. And this was the point 0, negative 1/6. And this was the point 0, comma, negative 4. What's the same about these? X is 0. Okay. So if I give you the picture, sometimes you can tell exactly where it crosses. If it crosses in an integer, you can kind of see that. Sometimes we're just looking at the graph. But a lot of times it's not going to cross in an integer. So what you're going to want to do to get the x-intercepts is you're going to let what be 0 for x-intercepts? Y. And to find y-intercepts, what are you going to let be 0? X. Just make sure that you write it down as points, and points are an ordered pair. Okay? So everybody good on x and y intercepts? All right, good deal. All right, the next thing I want to double check and talk about for a second is something called symmetry. Okay? Symmetry. Now, we're going to talk about 3 different kinds of symmetry. Now, you know what symmetry means. If I've got a flower arrangement that I do symmetric, if there are 2 red roses on the left, what do you expect me to see? 2 on the right. Okay? Now, there's lots of kinds of symmetry, but we're going to talk about only 3 kinds. Okay? We're going to talk about x-axis symmetry. We're going to talk about y-axis symmetry, and we're going to talk about origin symmetry. Now, I'm not saying that's the only kinds of symmetry there are in mathematics. That's just the 3 we're going to talk about. Okay? Now, the reason that's going to be helpful again is if something's symmetric, then you've only got to do half the work to get the whole picture. Okay? And, you know, we really like to be, let's say, efficient, not lazy. Okay? So it's really going to be helpful for you more later maybe than it is right now. Now, there are different ways of doing it, but to me, here's the easiest way of doing it. To check for x-axis symmetry, I want you to replace y with the opposite of y. And if you get the same thing that you started with, then you have y-axis symmetry. If you don't get the same thing you started with, you don't have y-axis symmetry. Okay? Now, what in the world do I mean by that? Okay? Now, what am I going to replace y with? So instead of squaring y, what am I going to square? But what's a negative y times a negative y? Y squared. Does this look like the same thing you started with? Then it's got y-axis symmetry. I mean, it's got, excuse me, x-axis symmetry. Now, here's what this graph looks like. Remember, we talked about when the x is squared, the probability goes up or what? Or down. When the y is squared, either goes left or what? Or right. Now, what x-axis symmetry means is if you fold along the x-axis. So if I took my paper and folded it right there, wouldn't this fit right on top of that? So that's what x-axis symmetry means. This is where you would be folding. Okay? So that's kind of doing it pictorially. But doing it algebraically, you replace y with a what? Negative y. If you want to check for y-axis symmetry, you're going to replace x with a negative x. Okay. And that's like the one we had a minute ago. Let's do this. And we did that one a minute ago. Remember? That's the one that looked like that. Okay? And see, how am I going to check for y-axis symmetry? I replace what? X with a what? Negative x. But what happens when you square a negative x? What do you get? So I would get y is x squared minus 3. Does that look like my original? It does, doesn't it? And see, think about it. Y-axis symmetry means you fold along the y-axis. So sure enough, if you were to fold along the y-axis, wouldn't this fit right on top of that? With origin symmetry, you do both. Okay? So you replace x with the opposite of x, and you replace y with the opposite of y. Okay, and again, if you get the same thing that you started with, then you got that kind of symmetry. Now, answer me this question. Let's do it this way. You know what cubic graphs look like? That's right, they look like an S curve. Anyway, one of those. Okay, now, so here's what happens. They look like this. Now think about it. Let's replace y with a negative y and what? X with a what? Negative x. All right, so in place of this y, we're going to put negative y. And then in place of this x, we're going to put a negative x. Now what happens when you cube a negative? It stays negative, doesn't it? Now here's where you got to be real careful though. Do you see that I get a negative y equals a negative 3x cubed? Now here's where you got to be careful. Does this look like the original? No, but I can make it look like the original by doing one thing that's legit in math. What can I do to both sides? You can think about dividing both sides by a negative 1 or multiplying both sides by a negative 1, depending on how you think about it. And if you were to divide both sides by a negative 1, wouldn't you get positive y is a positive 3x cubed? So then, does this look like the original? So before you write down no, in your mind at least multiply through and divide through by a negative 1 and make sure that doesn't fix it. Now what this means is you do a double fold. If you were to fold along the x-axis, wouldn't that flip that up there? And then when you fold again on the y-axis, it would flip this on top of what? On top of that. So the origin is like a double fold. Okay? So on a test, what I might do is something like this. Does that have x-axis symmetry, y-axis symmetry, origin symmetry, or no symmetry? Now, what you can't do on a test is go y or origin. You see what I'm saying? You have to show me that you checked for all three. Okay, how would I check for x-axis? Remind me what I do. Oh, so good. Okay, so I get a negative y is 6x squared minus 1. Does that look like the original? Now, before you write down no, let's double check. What if you multiply through by a negative 1? It would fix this one, wouldn't it? Or what would it do? It messed those up, so that's a no. All right, how would I check for y-axis symmetry? I replace them, what, the x? All right, so I have y is 6. Now I got a negative x that I've got to square minus 1. What happens when you square that negative x though? Okay. So does this look like the original? It does, doesn't it? So here I do have what? Y-axis symmetry. All right, how do I check for origin symmetry? Remind me again because I forgot. Good. All right, so I get a negative y, 6, a negative x. Okay. So I've got my negative y. What kind of 6x squared would I have over here? Good. So does that look like the original? No. What if I multiply through by a negative 1? Would that fix it? It fix this, but it mess up what? So do you understand how I do that? Okay? Now, let me show you another way that I might phrase it, and this is the way that's really going to be probably more helpful for you on your third test. What if I told you this? The point 2, 4 is on a graph. The graph has x-axis symmetry. All right. And here comes the question. Then what other point must be on the graph? Now, I'm not giving you the equation. All I told you is you got some graph and the point 2, 4 is on that graph. And I guarantee that that graph has what kind of symmetry? X-axis. So then you should know one other point that must be on your graph. Now, what does x-axis symmetry mean? What gets replaced on x-axis symmetry? What does y get replaced with? So what's this y going to get replaced with? And the other stays the same. Remember what I said, when you replace y with a negative y, it looks like the originals. Everybody with me? So you would know that not only is this point on the graph, what? That point's on the graph. So when you have to do that t-table by hand on your third test, when you've got like 3 points, if you know it's got x-axis symmetry without any work, you know another what? 3 points. Rather than you plugging and chugging 6 times, you've only got to plug and chug 3 times. Everybody with me? So you get double the stuff for half the work. Now, what if instead of saying x-axis symmetry, what if I changed it to y-axis symmetry? You write what you think is the point on your notes. Okay. So the point 2, 4 is on the graph, and your graph now has y-axis symmetry. And I ask you, what's the other point then on the graph? All right, what do you think's on the graph? Good, negative 2, 4. Does everybody understand why? Because when you say y-axis, what gets replaced? This x is replaced with a what? A negative x. What if it were origin symmetry? What would the point be? Negative 2. Yeah, y'all are good. I can't fool y'all. Now, do you understand, if this was the original point, though, you might think of opposite rather than just negative. Everybody with me? So if the original point had been 2, negative 4, what would the origin point with origin symmetry be? Negative 2. Yeah, negative 2, positive 4. Okay? And again, that's going to be helpful for you later, more than it really is now. Okay? Now, the other thing I want to talk about is sometimes you need to know where 2 graphs intersect. Like if you've got your book on page 6 down at example 5. All right, here's one of the equations they've got. All right, they've got x squared minus y equals 3. Holy moly, what's the, I can't believe, okay, that's the one I almost used. And then x minus y equals 1. Okay. Now, what kind of picture is this number? Let's call this number. If I number this one number 1, what kind of picture is this one? What's that going to graph for me? A parabola. Okay. Now, for you to use your grapher, which you can use on the first and second test, it's got to be in what we call standard form. So the y's got to be by itself. So everybody with me? So what would this look like in standard form? What would y equal?
X squared minus 3.
X squared minus 3. And you can get your grapher to do it. Now, does everybody understand that x equals y squared is your basic parabola with the origin at the centers of the vertexes at the origin? All right, what's that minus 3 do to that? It takes the whole graph and what? Drops it down 3. Okay? So that graph is gonna look like that. That's what we said a minute ago, where the x-intercepts are the square root of 3, 0, and what? Negative square root of 3, 0. Now, what does this one look like? Is that a parabola? It's a what? You told me a what? A line. Okay, again, if you want your grapher to do it, you gotta make it say y equals. So what's y gonna equal? X minus 1. Okay. Do those two graphs intersect? They do, don't they? How many places? 2. They intersect right here, and they also intersect what? Okay. Now again, if you take your grapher and you hit that tracer key, it's going to give you a decimal approximation here and a decimal approximation here. Am I going to like that? I need to know exactly what that point is and exactly what that point is. Now, here's what's unique about this. Do you understand that whatever this point is, the x-coordinate on the red parabola, if it's 4, the x-coordinate on the blue line is also going to be 4, right? So what I'm thinking in my head is I'm kind of thinking like this. The y on the line is going to be the same thing as the y on the parabola. Okay? Or I can think of it as the x on the line is the same thing as the x on the parabola. Now, one of those isn't better than the other, but one is easier. All right, and here's why one is easier. Now, you see how I've got the parabola kind of red and the line kind of blue? So do you understand what I'm saying is, I'm saying that either the y on the line is the same thing as the y on, well, I did it backwards. The y on the line is going to be the same thing as the y on the parabola. Or the x on the line is going to be the same thing as the x on the parabola. Now, one of those is easier to solve than the other one. What's the y on the blue line? Well, the y on the blue line is what? X minus 1. What's the y on that red parabola? Well, the y on the parabola is what? X squared minus what? 3. Now, what's the x on the line? Well, go down here. If you solve that for x, what would x be? Y what? Plus 1. All right. But you see how this one's going to be nasty? What's the x on this parabola? What if you solve that for x? What would you end up with? Well, you'd have x squared is what? Y what? Plus 3? So what's x? Plus or minus the square root of what? Which one of these you want to work?
The left one.
I think I'd work the left one too. Is everybody with me? So I can work this one, but I'm going to get extraneous solutions and have to do all of that. That's just yuck. All right, so let's review. This is a quadratic equation. How do we solve a quadratic equation? All right, but what have I even got to do before I got to do that? I've got to move everything on one side and have 0 on the other side. Now, it doesn't matter which side. If I put this over here, it's going to be a negative x squared. Would you rather be a negative or a positive? It doesn't matter, but most people want it to be what? That's fine. So if I take this and come over here, what kind of, plus x or minus x? Minus x. What you're really doing is subtracting x from both sides. Okay? And I've got this minus 3, but I've got to move this 1 over. How do you undo a minus 1? You add a 1. Okay? So I get x squared minus x. What's minus 3 plus 1 going to get me? Minus what? 2. Now I got two choices. You can factor it, and this one factors out pretty, which is really disappointing. Because in the real world, it never factors. Okay, now, so x and x. Now, does everybody remember, if this constant has a minus in front of it, that means I have one of each. If that constant has a plus in front of it, they're either both plus or both what? Minus, and that middle term tells you. Well, I'm lucky here because the only integer factors of 2 are 1 and 1. 2. Now, when they're opposites, I'm going to end up subtracting them, right? And I need to end up with a negative, so I'm going to need the negative in front of the bigger number. But you can just do it trial and error. You can do tic-tac-toe. I don't care what. You can ask Jesus. Whatever, just give me the answer that's legit, okay? Now, does everybody understand that that's 0? Now, take 3 seconds and multiply it back up and make sure you're right. X times x is what? X squared. X times a minus 2 is a minus 2x, and then a plus x. Does that give me that minus x that I need? Yes, because sometimes somebody will miss points on the test if they don't factor it right, because they didn't take 3 seconds to multiply it up. Now, here's what this says. This says that two numbers, this is one number, this is a different number. What do you know when you multiply two numbers together and the answer is 0? What do you know about one of the original numbers? It was 0. So either this first number is 0, I could write, or this second number is what? 0. Which says x is either a what? -1, or x is a what? 2. Does that make sense to everybody? Now again, aren't those points? What do we know about points? How many parts do they have? 2. So these are the x parts. So it's either -1 comma something or what? 2 comma something. How do I fill in that blank? How do I know what the y coordinates are?
Plug and chug.
Plug and chug. I don't care. Should you plug it into the parabola or the line, or does it matter? We said what? It doesn't matter, but I know what I'm plugging into. What? The line's easier. I'm squaring anything. All right, so what if I have a -1? -1 minus y is 1. So that's going to say a negative y is a what? 2. So what's y going to be? -2. Or if I plug in a 2, what's 2 minus 1? 1. See, the advantage of doing this, instead of plugging over here, I can just plug in what? Over here. So what do we get? I want to pay attention. 1, then that's what I want. And then go back and make sure it looks right. Does it look like, does 2, 1 look reasonable on your graph? You know, does -1, quadrant 3, -2, you have this down in quadrant 3. That looks reasonable. Now, it still may not be exactly right, but at least I'm not going to laugh at it. Okay. Now, what if the picture were like this, though? Oops. What if you graphed it with your grapher and it looks like this? Do they have to touch it all? Not necessarily. Sometimes you might try to do it algebraically and you get something like x squared is a -4. Is everybody with me? Which would tell you that you have no what? No solution. Couldn't it look like this? Couldn't the line clip it like right there? Then how many places do they touch? 1. So it depends on the parabola and on the lines. Everybody with me? Sometimes 2 parabolas touch in 2 places. Sometimes 2, you see what I'm saying? Like, depends on S-curves and parabolas. So if you look at the picture, you should know, am I expecting to get 1 point, no points, 2 points, 3 points? And then it needs to make sense to you. Okay. Now, is everybody with me so far? Now, I've got 15 whole minutes, so that's gonna be perfect. All right, let me show you why. Let me show you what most of my students do not know. I'm sure y'all are different than most. These are not the same problem. Let's make it something simple. You don't work on this. This is a quadratic equation. That's a quadratic inequality. The only thing that's the same is the first step. What's the first step on both? You told me to do what a minute ago? To factor, right? Now, what if they don't factor all three? What can you always use? Quadratic equation. All right, that quadratic form, is everybody with me? So if you need to Google that and look it back up, what is it? Remember the opposite of what? B. Plus or minus the square root of
Square minus 4AC.
all over.
Yes.
Somebody somewhere now is proud. If you're from Madison Central, you just sang it. Is everybody with me? Okay, which is well done. Okay. Now, so you need to know this. If it doesn't, you can always factor with this. It's just I tend to do trial and error real quick because it's quicker. But if it doesn't work, so for me, you can ask anybody who's had me before. You are very likely to get an answer like the square root of 17, comma 2 over the square root of 11. So don't panic because you don't get like 2. In the real world, no engineer gets 2. Okay, and my job is kind of get you ready for the real world. Okay, so if it doesn't factor off, we're going to use the quadratic formula. Now, helps if you write it in minus here too. Now, what do these both factor into? X what? Minus 3 and plus what? 2. You can do it by trial and error. Like I said, quadratic formula, tic-tac-toe, I do not care. Now, do understand, when you use the quadratic formula, it's always x minus and x minus. Always. The 2 answers you get with the quadratic formula go in the box. So if you get a positive and a negative, see what's minus and negative going to get you a what? You see what I'm saying? But if you're doing the quadratic formula to factor, it's always minus and minus. And the answers go in the box. Okay? Now, this one, everybody's good with. That one, y'all just blow up like I've never seen anything like it. You told me a minute ago, the reason it can work this one is when you multiply 2 numbers together and the answer is 0, you know that what? Either this one was 0 or what? That one what? Is 0. So you either get 3 or you get negative 2. Everybody cool with this? Now, this is not what this is saying. This says when you multiply 2 numbers together, the answer is greater than 0. Okay, what kind of numbers are greater than 0? Positive. So this says when you multiply 2 numbers together, the answer is positive. Correct? All right, when can you multiply 2 numbers together and the answer be positive? When they're both positive. Oh, or they're both negative. There's 2 possibilities. Now, the fancy word in math for possibility is case. All right? Possibility number 1. They're both positive. Or possibility number 2, what did you tell me? They were both what? Negative. Now, conjunctions are a big deal in math, but sometimes in high school they don't get emphasized enough for me. It'd be different if your dad told you, I'll buy you a new car if you make an A in calculus and organic, versus I'll buy you a car if you make an A in calculus or organic, right? Same thing here, ands and ors are different. Now, what does they're both positive mean? That means the first one is positive and or. If I'm saying both of them. And the second one has to be positive. That's the only way they both be positive. The first one's positive and what? The other one's positive. All right, when is x minus 3 going to be greater than 0? What would x have to be bigger than? Just solve that. How you going to get rid of that minus 3? Don't you have to add 3 to both sides? So it's going to be bigger than what? 3. And what about this one? How would you solve that one? X is going to be bigger than a what? Negative 2. Now, if you're a visual learner like me, you may need to draw yourself a picture. Three is somewhere over here, correct? So you're bigger than 3. Now, is 3 bigger than itself? No. So I'm going to draw an open hole. Is everybody with me? Bigger, right or left? Right. At the same time, x has to be bigger than a negative 2. And a negative 2 is somewhere right here. Is everybody with me? Open hole or closed hole when it's just greater than? Open. If it's greater than or equal to, it'd be closed. All right, open hole. And again, bigger means you go to the right. And where do you have both colors? Where are both of those true? When the numbers are bigger than what? 3. So the answer to case 1 is numbers bigger than 3. Now, let's go work out the other case. It's like a whole new problem. They're both negative. So my first number is negative, and my second number is negative. We okay? All right, when is x minus 3 less than 0? When x is less than what? 3, isn't it? And when's x plus 2 going to be less than 0? When x is less than a what? Negative 2. Are we okay? So again, and means you have to have both at the same time. Okay? So 3 is somewhere bigger, but this time I'm going to do less than, correct? So am I going to go left or right with less than? Left. To the left of, okay? And then when I want to do less than the negative 2 is smaller than 0. So I've got to go to the left of that negative 2, right? And what about and? Do I need both or just one color? With and, I need what? Both, all of them. Where is it smaller than 3? What numbers are smaller than 3 and smaller than negative 2? Numbers that are what? Less than negative 2. And these cases are joined with what word? Oh. So there's my final answer. Numbers bigger than 3, they work. Or numbers what? Smaller than what? Negative 2. So give me a number bigger than 3. 5. Okay, what's 5 minus 3? 2. What's 5 plus 2? 2 times 7. Is that a positive number? Yeah, see, it worked. Give me a number smaller than negative 2. Negative 4. Okay, a negative 1 wouldn't be because this is to the right. Is everybody with me? All right, so negative 4, okay? What's a negative 4 minus 3 more going to get me? Negative 7. What's a negative 4 plus 2 going to get me? And sure enough, a negative times a negative would be a what? If you try to number not there, you'll get a false answer. That's the way you work quadratic inequalities. Okay? Now, what if it had been less than 0? When can you multiply two numbers together and the answer be negative? Well, the positive and the negative. Which one though? You see, you still have two cases. It could be that this one is positive and that one would have to be what? Negative, wouldn't it? Or it could be the first one is the one that's what? Negative, and the other's the one that's what? Positive. So you see that both of those, you would have one each. Okay? So do you see that quadratic inequalities are longer than quadratic equations? Now, another day, I'm going to show you a shorter way of working it. Okay? But you need to practice some of the kind of a long way in order to understand it. And then I'll show you a shortcut, not today, but another day. Okay? Now, before I let you go, all right, let me come over here and do this real quick.